Okay, this time we're going to learn how to play a chained block puzzle, and we're going to try and solve this one as the example. It's not the simplest one, I don't think. It's like fairly big, but like there's got some interesting things going on in it, including a question mark, which we'll see what that means. Let's go to the rules. So, chained block rules. Shade some cells on the board to form blocks of any shape. So we're just shading in cells. We're not doing triangles this time, just shading in cells. Each block must contain exactly one number or a question mark. So this will be reminiscent of Nurikabe, which we played when we were doing Nurikabe World. So as we can see, like they're shading in like shapes like this, and each shape contains like a number. A number indicates the size of the block that contains it. Also very familiar from Nurikabe. Next constraint, diagonally adjacent blocks. So remember, a block here is like a set of shaded in cells that are all connected to each other. So a block, let's go down to the complete example at the bottom. This whole set of 4 shaded in cells is a block. This set of 1 shaded in cells is a block. This set of 3 is a block. So the shape of like orthogonally connected cells is a block. And so remember that definition. So diagonally adjacent blocks form a chain. So if they're connected to each other diagonally, they form a chain. A chain cannot contain 2 identically shaped blocks. Counting rotations and reflections is the same. So this is where this puzzle type gets really interesting. So we'll start with the example where it's right. So down here, this is a chain of blocks. And this is right because each of the blocks in this chain are different shapes to each other, right? Like this is just a single block, and the 2 threes, the one of them is like an L shape and the other one's just a long shape. Let's look at an example where it's wrong. Here's a chain of blocks. This 1, this 3, and this 3, but 2 of them are the L-shaped 3. And even though they're rotated from each other, that's bad. You're not allowed to do that. You can't have the same shape twice. You can't even have it reflected. Okay, so then that's that rule. And then 4, all blocks must be diagonally adjacent to at least one other block. So every block must be part of a chain. It doesn't necessarily need to be one chain. That's really important, and that could catch you out. Like in this example that they've given, there are 2 chains going on here, but every block is part of a chain. So here's the puzzle I've chosen for today, and we're going to give it a go. So where to begin? Well, just like in Nurikabe, if you have like 2 numbers like next to each other, you can immediately like separate them from each other, because if they were to join together, suddenly you'd have 2 numbers on a block, and that's not good. That tells us that this 4 is coming out this way. So there's definitely like some Nurikabe familiarity here. This 4 must come out this way. This 4 must come out this way. This 3 must come out this way. That 4 can't continue down this way because if it did, it would connect to this other 4. And even though, sure, they'd both be part of a 4 shape, they could only have 1 number on each block. So that's going to get cut off there. And then this must come out this way. We don't know which way the 4 is going to go after that. We don't know which way the 3 is going to go after that. But we can think about the shape of this 4 up here in the top left corner. Because if it were to be like, obviously it can't be a complete straight line 4, because that wouldn't fit anywhere. It's going to have to turn somewhere. But if it were to fully extend out, like as an L shape, for example, it would join to this 4 up here. That's not good. Can't do that. Or if it were to like zigzag, it would join to that 4 up there. So what shape can we even do that doesn't join to this 4 up here? There's only one. It's a T shape. Once, just like in Nurikabe, once you've like got kind of a block defined, you can like mark the spaces next to it to say that they're necessarily going to be empty, which is handy. So we know this 4 continues along this way. And so here's where things like start to get interesting. We've got a chain forming here, right? We've got 3 4s in a chain. None of these 4s can be the same shape as each other. So you start to like constrain the shape of other 4s because we know T shape is already done. We can't do another T shape. What else can we figure out here? So yeah, so we know this can't be this because then we've got 2 T shapes. We also know it can't be like a zigzag shape because it would join to 3, and it can't be an L shape because it's joined to that 3. And so one of the things to get used to is like all the possible ways of drawing 4s. Like it's basically like the shapes in Tetris. So like that's a 4, that's a 4, that's a 4. That's a 4. And what have I missed? T? Did I get all of them? There's only a few, right? Obviously, there's reflections of those and rotations, but those are the options. Okay, so this 4. Basically, I know at this point that it can't be an L, it can't be a Z, so it's going to end up being the I shape. Cool, so that connects to there. So we have another 3 joining the chain. So we've got the 3 over here and this. Oh, also, just like in Nurikabe, if we have numbers that are near each other, we can separate them from each other, just like that. So we should have done that earlier. Also, because the 4's done, we can mark off all the stuff around it. Need to not forget. But yeah, another 3 is joining this chain. And so something that's interesting about 3s is there's only 2 ways of drawing a 3. There's you can draw it as a straight line, or you can draw it as an L shape. So that necessarily means, since we've already got 2 3s in our chain, this 3 isn't going to be part of it. There's not going to be another 3 part of this chain at all. This 3 must go down. It can't turn that way. It could turn that way, but if it turned that way, it would join this 3 into the chain, and we can't have more than 2 3s in a chain. So it has to be a straight 3 like that. That tells us that this 3 is going to be either that or that, and I don't think we can say for certain yet, but it does tell us it's not going to go there, so we can mark that off. We can also mark all of these off. Isn't this fun? Well, okay, so now what can we say about this 3? This 3, if it were to go that way, would join this chain. Oh, I mean, so it would also force that 3 to go that way, but it would join this chain, and then we've got a problem because we've got too many 3s in a chain. So it can't go that way, so it's going to go down. It's going to be that shape. I still think that doesn't tell us what we do with this 3. Either goes that way or that way. It does, however, mean we can mark that off. So something worth mentioning that wasn't in the main rules is that a question mark is basically just like any number. So this is going to be a block that is of any size. And I think the puzzles that have question marks in them are usually like the most interesting ones, at least to me. Okay, what can we do with what's going on up here? We've got a 2 and some 3s as well. Let's say this 2 were to go that way. It needs a friend. Okay, so here's the thing. So one of the rules is that every block needs to be part of a chain, right? So this 2 needs to join to something. It can't join up here because it's not long enough to get to this chain. And so it's going to have to be joining. The only route out of here is down to these 3s down here. Now, the problem is if we were to go that way, this 3 wouldn't be able to connect to it at a diagonal. It'd be able to connect to it like this, but then we formed a bigger block, which isn't good. We can't connect to it at a diagonal. So it must be going that way. And we shade these off. It must be part of a chain, so that must be part of a thing. So I imagine this 3 might be like this, right? And that actually tells us, well, that's cut off. So that actually tells us that this space can't be filled in. Because like this chain could continue down here, right? But if it did, we'd have too many 3s in this chain. And there's not enough 3 shapes to be able to do that. So that's not part of it. So that chain ends there, that chain ends there. It's just a short chain of 2 things. Alrighty, next up. Okay, so shapes of 4s that we've got up here. We've got a I, we've got a T. So this is either gonna be an L or an S. Now, if it were an S, so it would come down to here, this is gonna cause a problem for this 4 down here. It just doesn't have space. You can just like visually see it doesn't have space to like fit 4 in without joining to another cell. So that's immediately gonna be a problem. So I think the only thing we're left with is an L, so it's going to have to go that way. That tells us that 3 goes to that direction. That goes like that. Neat. So let's work on this bottom corner here. So this 4, so this 4 is pretty constrained. It doesn't have a lot of space to work with, right? Like it can't go into here. In fact, if the 2 went up that way, the 4 definitely wouldn't fit. So the 2 definitely doesn't go up that way. How else can the 4 fit? Well, it can't be an I going out like that. It can't be an L going like that. So I think it has to be an L going like this. That means the 2 doesn't go this way, it goes that way. And this 4 is joining with this 4 over here and this 2. So note that chains can have like kind of loops in how they're connected. That's totally fine. Like this 3 is connected to this 4 in like 2 places. That's totally fine. This 4 is connected to this 4 and to this 2, and those 2 are connected to each other. That's also totally fine. Cut off the surroundings of this 2. Cut off that. So this 4 has to continue this way. It can't go that way. And the 4 can't go this way. So it has to come upwards as well. What shapes do we have? We've got an L already, so this isn't going to be an L. So this is going to have to be an S shape. That's all that's left that would work with this, right? So we can't do a T shape, can't do a long shape, so it's going to have to be an S shape. This 4 is continuing this way. That's going to cut off there. Nothing's going to go there. That's like just a space that's not going to have anything in it. So like we've got an interesting problem here, right? Is that we've got a 3 up here that's by itself. It's all by its lonesome. It needs a friend. Where's it going to get the friend from? None of these numbers, that 4 can't reach up there. I mean, the 4's already done. This 4 can't reach up there. That 3 can't reach up there. So there's a question mark down here though. So I think I found a friend for the 3 up here. This 3 is going to be friends with this question mark in some way. We don't know exactly how, but it's going to somehow work its way up here. What shapes of 4s can we do down here in this chain? We've got an L shape, we've got an S shape, so we're left with an I, which we can't do because it would connect to the question mark, a T, which is possible, an O, which we can't do. So it's going to have to be the T shape, right? That is true. That tells us that's cut off. So this question mark is going to come up this direction. And that's definitely can't have a thing in it. Okay, so this three needs a friend. So it has to go this way. Then that has to continue this way. This is always a fun bit in these chain block puzzles, is you start doing a block not starting from a number. Like, well, this needs a friend, so this has to be filled in, right? And that's going to have to continue somewhere. It's going to have to get to a number somewhere. So it's going to have to go that way. It can't go this way because it connects to the 3, and that would be too big for a 3. So it has to go down here. I think you can see where this is going to go. It's going to go down here. And this is clearly going to have to be the question mark at this point. I guess we knew that anyway. It can't go that way because it would connect to the 3. So it has to zigzag down this way, zigzag down this way. Let's finish the 3 off. It's going to have to go there. And so this is going to have to go that way. And we're done. It was indeed a very generous question mark. I think chain block is awesome. Such a fun little puzzle type. Especially when it's got these like question marks in it and you like go, oh, but this chain needs to connect to this thing over here. How are they going to get to each other? And yeah, it's cute that this question mark just zigzags up to get to the 3. Super neat. Okay, cool. That was chain block.